Okay, we want to evaluate the following limit using an infinite series. And as we see this, we see that we have this square root of 1 plus 3x. And we have this Taylor series that's called the binomial expansion. You learned about binomials in college algebra. Anyway, so we have the same thing, but instead of x, we have a 3x, and instead of a k, it'd be to the 1/2 power for that square root. So we're going to use these terms, but we're going to put in 1/2 for the k, and we will put in 3x where the x is. So let's go ahead and write this out. So it's the limit as x goes to 0 of 1 plus 1/2, and then we're putting in 3x, and then plus, I'm just simply plugging these in the different terms here. We've got a 1/2 times 1/2 minus 1 over 2 factorial, and then 3x squared. So I've got that one. Now let's go ahead and do this next term. That's going to be 1/2 times 1/2 minus 1 times 1/2 minus 2, and that's over 3 factorial and 3x cubed, and that will continue on. And then we also have these other two terms here, so let's put those on. Minus 1 minus 3x over 2, and that whole thing is over 3x squared. So let's see what we can do now to simplify. This minus 1 and this one cancels, and this is 3/2 x, so that'll cancel with the minus 3/2 x. So let's see if we can rewrite what we've got left so that we can evaluate it when x approaches 0. So in looking at this next term, we have a 1/2 and a minus 1/2. That would be minus 1/4 over 2 factorial, so that's times 1/2. And then we have this 3x squared, which will be 9x squared. And let's apply the denominator. That's over 3x squared. Looking at the next term, we have a 1/2 and a minus 1/2 and a minus 3/2, it looks like, over 3 factorial. And then we have this 3x to the third. Okay, so, and then we still have the 3 factorial. So let's see if we can combine all that. So this part would be 3/8, and then our 3 to the third is 27, and x to the third, and then that's over 6, which is 3 factorial, and then that whole thing is over 3x squared. Okay, and then we still have lower terms. Now as we look at this x squared will cancel with this x squared, and so this term does not have an x in it. However, subsequent terms are going to have x's because you're going to reduce them with an x squared, and for example this one will leave an x, and the next term it will leave an x squared, and the next one an x to the fourth. So as we do the limit, these guys with x's in them go to 0. So our final answer is just whatever we'd get if we simplify this one, and it looks like we've got negative 9/8 over 3, so let's flip that 3 over, and the 3 will reduce with the 9, and final answer negative 3/8.